All right, so now we're going to apply our idea of positive, negative, cosine and sine and tan values and think about what that means if we're just given a point. So we've got a point on a terminal arm of an angle theta. We want to draw the angle in standard position. So remember that means we're going to start at the origin. We're going to put the vertex at the origin. We're going to then make our initial arm the x-axis, and theta is going to go this direction. Then we want to find sine, cosine, tangent, and then finally we're going to find the angle theta. So let's start with this first one. I'm actually just going to do this. I'm going to give myself a little start for all of these. Let's do that again, and then do that again. I should have done this before I started the video, sorry. Okay, so the first one is the point 2,5. So I know that 2,5 is going to be roughly here. So I'm going to stop my angle up at that point. So there's my theta. I'm going to make a triangle. So theta is inside here. My adjacent side is 2. My height is 5, and I know that by my coordinates because that's my length and that's my height. And then I can use Pythagorean theorem to find my r value. So 5 squared plus 2 squared, that's going to be 29. So this side is going to be square root of 29. I'm going to leave it like that. I don't like decimals. I know that 5 and 2 are both positive. We're in quadrant 1. So sine of theta is exactly 5 over root 29. And I'm not going to rationalize the denominator here because I like to see opposite side and hypotenuse. Cosine is 2 over root 29. And the tangent value is going to be 5 over 2. Notice, written this way, I can just ignore those root 29s because they'll cancel each other out. So tangent is my sine over cosine. And then I want to find the angle. I can pick any of these to help me find the angle, and I can use the inverse trig function to find it. So I'm going to tuck this in a bit here. Okay, maybe that's a bit too small. All right, so I'm going to go into, first I'm going to look and see on my screen. I'm in degrees. It doesn't say, so that means I'm going to go to radians because we are sophisticated mathematicians. So I'm going to go doc, and then into my settings, document settings, and instead of degrees, I want to have radians. Okay. I know that this value for my angle should, and I'm approximate again because I know this isn't one of my special relationships, and none of those numbers I have memorized. So I'm going to go into trig, and then I'm going to do sine inverse because it's just the first one that's there. So my sine value was 5 over root 29. I know that that angle is going to be between 0 and pi over 2. Pi over 2 is about 1.7. So it should be something between 0 and 1.7. So 1.19 radians is that theta value. So theta approximately 1.19 rad. All right. Now this time, -3 and so x value is -3, y value is 6. That is not very accurately drawn. Let me tuck it in some more. So that, and then double that. All right. And that fits nicely. But I'm going to draw my triangle this way because even though that fit nicely, that's not actually where the angle stops. So I'm going to erase that. I don't want to erase all of that. I want to erase just, will it not let me erase just that bit? Well, okay. I guess I have to deal with that. So I'm gonna come in over, double that height. So there's my point. So my angle is gonna go to that terminal arm there. This x value is a -3. I know the length of that is 3, but the x value is -3. The y value is 6. So when I do my sine value, I'm still going to get a positive. My sine theta is going to be 6 over 36 plus 9 is 45, so that's root 45. So 6 over root 45. The cosine is going to be negative 3 over root 45. My tangent is also going to be negative, and this time it's going to be negative 2. 6 divided by negative 3 is negative 2. And so now I want to be careful with using my inverse sine or cosine, because if I just went over here and said inverse sine of 6 over root 45, it's going to give me a positive value, and it's going to give me an acute value. So instead, I could do same as I did here, but now, oh, I can't tell it what I want it to do. So if I did my sine inverse of 6 over root 45, I hit enter, it gives me an acute value, but I know I don't want the acute value. I don't want this acute angle over here, which is going to match my reference angle. So that acute angle that it just told me is my match over here. I actually want to have pi minus that reference angle. So I'm going to come back to my calculator, and I'm going to say pi minus that reference angle, which is that value. And so now I get 2.03. So theta, approximately 2.03 rads. If I had done cos inverse with the negative, so let's look at that. Control, trig, not control trig, not control. Oh, goodness. Just trig, cos inverse, negative 3 over root 45. This time, notice it gives me, oh, the angle I wanted. So, doing cos inverse there would have been the smarter thing to do. Make sure you know where you want your angle to be so that your calculator is telling you what you want to find. I'm going to leave you to do these two on your own. Come back and check the solutions, and as always, come ask questions in office hours or post them to our document.